In this lesson, we'll look at how the concepts of retrieval strength and storage strength relate to effective study strategies. In past lessons, we examined the concept of storage strength, and this is related to the strength of the memory trace in the cortical memory systems as a consequence of consolidation. You'll recall that consolidation was this reorganization of the memory so that cortical systems become more significant for later retrieval. We can think of the cortical memory as being strengthened with repeated rounds of consolidation. And we noted how that was different from a computer memory system where when data gets written to the hard drive here, it's not that some data is strongly stored and other data is weakly stored, but brains seem to operate this way. In addition, storage strength is related to how interconnected the piece of information is with other things in semantic memory. So a well-integrated bit of information will be well stored. So storage strength is a measure of how strong the memory is stored and how interconnected it is. Retrieval strength was a measure of the ease or speed of access of the information. But we said there were two ways that we might have high access or high retrieval strength for a memory. The two ways where we might be enjoying the working memory boost, where recently activated information is easily retrieved. And we said that was due to the fact that there's a temporary increase in synaptic strength in whatever neural circuits were recently used, so they can be easily reactivated. And that would be what it is to have easy access, to easily retrieve some information you were just thinking about or reading over. But in addition, we can have high storage strength. So information that is well stored, has high storage strength, is easier to access and retrieve. So there are two ways then to have high retrieval strength, but retrieval strength is a measure of the ease or speed of access in retrieving the information. Now let's get to some of the illusions or the common pitfalls for students who are studying. One of the important misconceptions that Bjork and others have identified is that during a study session, students may believe that the ease of retrieval during a study session is a good measure of the long-term storage of the information. And this is false. The ease of retrieval could be due to the working memory boost. So the take-home message is that high retrieval strength during a study session just means high retrieval strength during the study session. It is not a good indicator of the strength of the storage of the information. And again, this is because there are two ways to have high retrieval strength. It might be the working memory boost, or it might be that the information is well stored. But you can't tell in the moment of a study session which of these possibilities is really the case. So, what we're going to have to do to assess storage strength, we're going to have to try to retrieve the information after a delay so that the working memory boost is gone. And so this is an important implication for good study strategies. We want to space out our study sessions so that retrieval strength is a better measure of storage strength. Only if we wait for a long enough time that our working memory boost disappears, only then, if we can easily access information, is that a good measure that it is well stored in our long-term memory system. Another way to think about this misconception or this study illusion is to think about the difference between understanding something versus remembering. So students may feel like they understand what they are studying, but understanding is not the same as remembering. The only way to find out if you will remember what you understand is to test yourself later on. So as we study, we're reading, and it all might look familiar and we understand it. But that feeling that you understand something is not necessarily a good indication that you will remember it later on. You must test yourself later on after a delay. So to illustrate the differences between, retrieval strength and storage strength, let's consider two students, each of which has high retrieval strength for the same item of information. Now, there might be two different reasons for their easy and fast retrieval. Let's say Jack here was recently studying the information for the first time, so he enjoys the working memory boost. So he's just been looking over the information. He could put the book down and retrieve the information. He has high retrieval strength. Jill has learned the information on repeated occasions, right? So repeated consolidation events. So that piece of information has high storage strength in her long-term memory system. So she has high retrieval strength because the information is well stored in her long-term memory system. Now, to measure the strength of their long-term memory for the information, we must wait until Jack's working memory boost disappears. That is, we must delay our assessment to accurately measure storage strength. So he's just been reading information. Jill has already learned the information well, but what we need to do is wait for a time before we retest, and this will guarantee that Jack's working memory boost will disappear. And when we assess later on, Jill's going to win. So her high storage strength meant that she retained the ability to retrieve the information over long delays. She didn't forget quickly. Remember the fundamental relationship between storage strength and retrieval strength. The storage strength determines the rate of forgetting. Because she had high storage strength, she did not forget very quickly, so she was able to retain access to the information. On the other hand, Jack, his low storage strength meant that he quickly lost the ability to retrieve the information over long delays. He forgot quickly. So what we want as educated individuals is to have long-term access to information. And for that, we need to achieve high storage strength for the information. This will allow us to retrieve the information at long delays. Now, let's consider an interesting counterintuitive relation that Bjork and colleagues suggest. The higher the retrieval strength, the smaller the gains in storage strength with additional practice. In other words, when information is highly accessible, it is difficult to increase storage strength. And this means that further study is less valuable. You approach a point of diminishing returns with further study. Now, this is interesting because lots of students think that long study sessions mean that they're going to benefit greatly from long study sessions. And Bjork and colleagues are arguing that actually is not the case, that you can reach a point where you'll have diminishing returns. Because when the information is already highly accessible, because you've been studying for a while, it's more and more difficult to increase the storage strength. And that, after all, is the ultimate goal of our study practices. So this leads to another version of the study strategy number one. Another benefit of spacing out study sessions is that retrieval strength is going to be lower for the next study session. So you see, in order to boost storage strength, we ideally want to set up our study sessions so that retrieval strength is low. Again, because of the counterintuitive relationship, when a high retrieval strength is in play, because we've just been reading the information, it's hard to make gains in storage strength. So we have to wait. We have to wait for a while so that our retrieval strength diminishes. And then when we restudy, we'll be able to boost our storage strength. And Bjork has a little phrase that's kind of intriguing and again shows the counterintuitive notion that forgetting is the friend of learning. A delay between study sessions leads to a reduction in retrieval strength as the working memory boost disappears. Restudy during low retrieval strength will do two things that are beneficial for learners. It will calibrate the student's metacognition, so it'll be a better measure, as we've seen, of their storage strength. But it's also going to trigger a new round of memory consolidation. And remember, it's the consolidation processes that strengthen memories in the long-term memory system. So repeated study after a delay does two really good things. It's going to tell the student how well they have stored the information in the long-term memory system, and it's also going to trigger a new round of memory consolidation to make that memory even stronger. Now let's move on to another effective study strategy. Use a lot of retrieval practice. And this means quizzing yourself, testing yourself, not simply rereading information or looking over notes. Experiments on study strategies show that retrieval practice is superior to rereading or looking over notes. Simply rereading text information does not produce the same gain in storage strength. The information is reprocessed and recognized, but the effects on long-term memory are smaller. Psychologists are studying exactly why this is the case. So in our diagram here, we've sort of indicated that when we're rereading information, which is a very common study strategy to reread the chapter or rewatch a lesson, there appears to be less consolidation happening. We get smaller gains in storage strength as a result of that study technique compared to retrieval practice, where we're actually retrieving information using a cue to access a stored memory trace. Now, one hypothesis for why this is the case is that when we reread or look over our notes, our memory retrieval systems are not engaged. Better retrieval may require exercising those networks so that typical cues more effectively activate the relevant memory trace. Alternatively, retrieval practice may trigger consolidation processes better than rereading. Whatever the cause, storage strength is best increased by engaging the memory retrieval systems, what we call retrieval practice, or what many students do already add in their study sessions, and that is quizzing yourself. And a final strategy for effective learning is to use repeated study sessions with sleep intermixed. So it turns out that scientists have gathered lots of evidence that important memory consolidation processes are occurring during sleep. So sleep is a really important factor to consider if we want to store information into the long-term memory system. And the repeated study approach, of course, this will set up multiple rounds of memory consolidation. And every time we consolidate, we're going to strengthen the memory trace in the cortex. So we want to get our sleep, we want to use repeated study sessions spaced out in time, and we want to use retrieval practice as much as we can. So if we ask the question then, sort of in summary, how best to increase storage strength, Bjork has coined a phrase here that he calls desirable difficulties. These are difficulties because they appear to be sort of more challenging for the learner in the moment, but they're desirable because they lead to increases in storage strength. They lead to positive outcomes. And one way to think about this is make retrieval difficult. So that is the conditions of low retrieval strength. And remember, forgetting is the friend of learning. And we can do this by spacing out our study sessions. That will lower the retrieval strength. Using retrieval practice, that's more challenging, right, to access the information rather than rereading information or looking over notes. And strategy 3 is change the context of learning. Change the study location, mix up the study topics to force more difficult retrieval. So there's evidence that mixing up different topics does make retrieval more difficult, but then you have gains down the road. And remember to check forgetting after a delay. Many students seem to underestimate how much they will forget. We must check for forgetting after a delay. You can't do it right away because you're enjoying the working memory boost, so you have to wait a while and then quiz yourself. With the reminder that understanding is not the same as remembering. So when we're studying and we think we understand stuff, that does not necessarily mean we'll be able to remember it later on. And be careful with long study sessions. They lose their value. And scientists hypothesize that it may be because synaptic plasticity may have reached its limits in the relevant learning circuitry, for example, the medial temporal lobe, the hippocampal system. So as we lengthen our study session, we might think we're doing good things for our storage strength, but we may already have maxed out the synaptic plasticity for that particular learning session. We need to create a delay so that we can reduce retrieval strength and allow those synapses to return to baseline. And one of the things that scientists think is going on is during sleep, actually, some of these synapses that were increased during the learning session during the day, they get downsized. They get sort of reset during sleep in preparation for new learning the next day. So we don't want to just use really long study sessions because they lose their value after a while. And then finally, lots of psychologists argue that using deep processing, whenever you're kind of studying, whatever you're studying, you want to use techniques that facilitate deep processing of the information. Now, what is deep processing? Well, deep processing helps to integrate new information into the existing web of knowledge. You'll recall here, this individual on the left here, the concept photosynthesis is not well stored and it's not well integrated. Well, one way then to learn about photosynthesis is to use deep processing techniques where we're going to elaborate. So we're going to try to connect up photosynthesis with other concepts we already know. We want to make the new information distinctive. How is it different from something else that we already know? We might want to relate it to the self. How is it relevant to the self? And in all these ways, we can more effectively integrate new information into our already existing web of knowledge. So deep processing techniques help us add new information to our semantic memory. Now, finally then, let's consider these study strategies from the point of view of metacognition. And many students suffer from misconceptions. So here are a couple important ones. Students mistake retrieval strength for storage strength, and they stop studying. They think they know it. They think understanding in the moment is the same as remembering at a later time. The reality is that retrieval strength can be high because of the working memory boost. What we want to test is the strength of retrieval strength after a delay. Then it's a better measure of storage strength. Number 2, students think that long study sessions are valuable. In reality, when retrieval strength is already high, it is difficult to make gains in storage strength. Again, we want to space out our study sessions to make retrieval strength more difficult or lower, so retrieval is more difficult, or use other techniques that make retrieval difficult. Number 3, testing only measures prior learning. In reality, retrieval practice helps the brain increase storage strength. So testing isn't just showing what you know and don't know, it's actually helping you learn the information in the first place. But notice, all of these misconceptions are standing in the way of students using best practices. So Bjork and colleagues and all the psychologists who studying have pointed out something really important. We might think we know how best to learn. We might think we know how learning and memory operate, but we might be mistaken. And these misconceptions then are hindering our ability to maximize our learning success.